Welcome to this Nordic partner webinar. Today we will talk about how to integrate Bluetooth direction finding with u-blox. I'm very happy to see all the attendees here. So just a few words about myself first. My name is Petter Myhre and I'm a product marketing director here at Nordic Semiconductor. I'll be your host today, but I will be mostly behind the scenes. So let me introduce the main speakers today. Yorgos Marakis.
Hello. Hello, everyone. My name is Yorgos Marakis, and I am product manager, part of the product strategy team for short-range products at u-blox, and it's a pleasure to be here.
Thank you. And Erik Harberg.
Yeah, hello everyone. I'm Erik Karlberg. I'm also product manager at u-blox, and I've been working with our Bluetooth modules for a long time, and also for with our Bluetooth direction finding products that we'll talk about today. So I'm a pleasure to be here.
Thank you. Then just quickly some practicalities before we jump into the presentation from u-blox. So the webinar will last for approximately 1 hour, 45 minutes presentation, and then we will have a Q&A in the end. So please put your questions in the top of the right sidebar. And all questions are anonymous and try to keep them relevant to the topic, and we will answer them towards the end. You can also use the chat, but please try to avoid using that for questions, but feel free to engage and discuss and so on. If you have more questions, you can go to DevZone for Nordic related questions. And u-blox also has a support portal where you can ask questions to u-blox. And as always, a recording of the webinar will be available together with the presentation at webinars.nordicsemi.com. Then I'll hand it over to Erik to start the presentation from u-blox.
So thank you for the introduction, Petter. So from u-blox side, we wanted to show you a bit of what we have done in terms of Bluetooth direction finding products. So we will first start with an introduction, a very short introduction to u-blox, the company, then moving over to a brief presentation of Bluetooth direction finding, the technology. And as I think most of you know, there was an excellent webinar last week that Nordic provided. And if you're looking for details into the technology of direction finding, I strongly recommend that session because that was awesome. Then we go over to the use cases that we have experienced with Bluetooth direction finding, and then moving on to the product offering that's coming from u-blox, some demonstration and some words about how to get started, and then we wrap up with a Q&A. So an introduction to u-blox then. So we are a Swiss company. We're listed on the Swiss Stock Exchange. Our revenue for the first half this year was almost 300 million Swiss francs. That's roughly the same in US dollars, so it's almost a one-to-one exchange rate right now. Our guidance for the full year is a bit north of 600 million. Our products serve 3 core markets: automotive, industrial, and consumer. We were founded in 1997, so that's 25 years ago, as a spin-off from the Technical University in Zurich, the ETH. Out of our revenue, we spend almost 18% into R&D. And we have a broad customer base, so we serve 14,500 customers worldwide. Our employees are more than 1,200 persons. Out of them, 66% are in R&D. And we have had a continuous growth. Here an example of 12.5% per year since the introduction on the exchange. The products that we offer is, first of all, we have modules and chipsets for satellite-based positioning for outdoor usage. That's GNSS, GPS, Galileo, GLONASS, etc. We have cellular communication, and we also have short-range connectivity with Bluetooth and Wi-Fi. In the positioning product offering, we have developed our own chipsets, and also within cellular, we have in-house silicon for some of the segments. But for Bluetooth and Wi-Fi, on the other hand, we have partnered with market leaders like Nordic, taking their chips, putting them into small form factor modules, and thereby facilitating a smooth integration into end products. On top of this, we also have a portfolio of services that enhances this hardware-centric offering. These services are for location, communication, and security, and that complements our other products. So that was a very brief intro to u-blox, and we move over then to Bluetooth direction finding and the main topic of this webinar. So, as I think most of you know, Bluetooth 5.1's main feature was direction finding, and there are two methods for determining direction: angle of arrival and angle of departure. And we will look more closely into angle of arrival because that's the technology that we have selected to use for asset tracking and indoor location and indoor positioning use cases. So actually what we've seen with angle of arrival is that we can enable really high accuracy indoor positioning. We'll show some proof points of that during this session. But as I said in the beginning, if you are interested in the details, the technology details of direction finding, I strongly recommend the Nordic's webinar from last week, which should be available from their website. Go on to next slide. Yeah, thank you. So this is a slide just showing briefly the architecture of angle of arrival. So on the left-hand side, you have the AUA transmitter, which has a single antenna, and it transmits a continuous wave. On the right-hand side, you have the AUA receiver, which has multiple antennas and switches in between these antennas and receives the signal on all of them. But thanks to this switching pattern, they can measure the phase. It can measure the phase difference between the receiving antennas, and then the receiver is able to sample that phase information and calculate the incoming angle. And having the direction to the transmitter from several reference points, you can do a triangulation. And by doing that, you can then estimate the position of the transmitter. And using Bluetooth AUA, we can get a positioning accuracy that is lower or better than 1 meter. And here is an example of how a positioning system with a Bluetooth angle of arrival can look like. So you have the tag in the bottom that transmits the advertisement messages. You have anchor points which receive the messages with their antenna array, and here you calculate the angle of the incoming signal. So all of those 3 anchor points that you see here in the picture, all of them calculates the angle to the transmitter. So the readings from one anchor point gives you the angle, and then you can combine readings from multiple anchor points in a positioning engine and calculate the position. So if we then continue to the use cases that we have experienced when working with the different customers in this with this technology and the product that we're offering. So obviously, indoor positioning is one use case, but we've found that there are many others that are equally interesting. So the first one here we call Follow Me. So this is a device that follows a person or an object based on an angle based on the angle to the person or the object. So this could be a video camera that follows a person moving in front of it. It could be a golf car that follows the player on the court. Another one is access control, and this is a detection of how an object or a person is moving in front of a door or a gate. It could also be detecting if a certain person has passed through a door or a gate or a vehicle like a forklift and so on. And finally, collision detection, where moving objects are detecting the angle and the distance to each other in real time and avoiding collision. And then, of course, we have the indoor positioning and the asset tracking, which is the most common use case that most people think about. Here is about finding and tracking an asset, have an accurate inventory or optimized process in a factory. It could also be people tracking to locate a person, or when it comes to safety for workers or in emergency situations. You can analyze people flow in a building, or you can personalize the environment where a specific person is located. And finally, some applicable market segments for asset tracking. So, for example, in a hospital or a medical facility, tracking the equipment that you have could help you reduce the number of units that you need for a specific kind. For example, the hospital beds. If you know where all your hospital beds are, then you don't need to have an overhead of those. Or you can track the personnel, doctors and nurses, and make sure that they move most efficiently through the building. Factory, here you can track forklifts and goods, robots and tools, making sure that your production and manufacturing processes are optimized. In retail domain, analysis of the consumer behavior could be very beneficial. And then finally, of course, warehouses to accurately track your inventory at all times. So with this, we now move over to the product offering that u-blox have within Bluetooth AOA, and I hand over to Georgios.
Thank you very much, Eric. So in the next section, I'm going to be walking you through the line of products that make up the u-blox Bluetooth interpositioning solution, and taking things from the beginning. u-blox is a market leader in outdoors positioning. So a couple of years ago, when we decided to expand this expertise to cover the indoors spaces as well, we decided that Bluetooth was the right technology for accomplishing this. And we were lucky enough to have a wide portfolio of Bluetooth modules, most of them based on the Nordic semiconductor chipsets. And Nina B411 in particular was the variant that was optimized for Bluetooth direction finding. And our team of developers worked on an angle calculation algorithm that was implemented as a software package specifically for the Nina B411 module. And the specific software was called u-Connect Locate. What u-Connect Locate is, it's an in-house developed embedded software that performs high accuracy Bluetooth direction finding, and in particular the angle of arrival method described by the Bluetooth 5.1 specification. And in doing that, it provides to our customer faster time to market for their Bluetooth positioning products, and the angle calculation is efficiently implemented for the embedded MCU of the nRF5283 chipset. Our talented team of software developers added more enhancements to it, such as suppression of multipath components, and of course an easy-to-use command API that allows our customers to interface their application with our u-Connect Locate software. Last but not least, u-Connect Locate has been built on the Nordic NRF Connect SDK, specifically version 2.10. So then, of course, we want to give the chance to our customers to evaluate Nina B411 and Uconnect Locate. And we thought that the best way to do that was by designing an antenna board for it. So it's an antenna board that has 5 antenna elements. It has Nina B411 integrated, and Nina B411 runs the Uconnect Locate software. And we put this antenna board to 2 Explore kits. We have Explore AOA 1 that includes 1 antenna board and 1 tag. It's for evaluations of a simple direction finding system, so you can move the tag and monitor the angle as it is displayed on a graphical user interface or logged in the UART output of the antenna board. And we have Explore AOA 2 as well, which is a complete interpositioning system. And as Eric mentioned, and last week was covered at length by the Nordic webinar, in order to be able to track a tag and determine its position, you need several angles coming from several antenna boards, and you need some mathematical operations such as triangulation in order to determine the exact position of the tag. And therefore, Explore AOA 2 has 4 antenna boards, so the 4 angles go to a high resolution positioning engine that we developed. And in there, there's the mathematical operations like triangulations that are performed. And the final version of the tag is displayed on a graphical user interface developed by our partners, Traxmate. A few more words on Traxmate. Traxmate is a complete enterprise asset tracking. It's cloud-based, and it's very easy to use. Our users can create buildings and upload floor plans and manage the placement and configuration of the BLE anchor points in a web browser. So there's a 3-month evaluation license included with Explore AOA 2. And it's a very close cooperation that we have with Traxmate, and it's a collaboration that will continue in the future as well. So the feedback that we received from Explore AOA 1 and 2 has been overwhelmingly positive, and that motivated us to take things to the next step. So we took the antenna board that we designed and we added some enhancements to it and some improvements. The most important of these were we increased the number of antenna elements from 5 to 8, and we replaced the multiple RF switches with a single RF switch, thus minimizing errors and losses. And those 2 improvements alone further improved the performance of the antenna board, but also we made a design that is optimized to go to high volume production. So this is no longer an evaluation product. This is a product that goes to mass production and can be purchased by our customers and integrated in a straightforward manner to their end products. And that product is ANB10. It was launched earlier this year. And what ANB10 is, it's an antenna board that enables you to build and implement interpositioning systems. And by doing that, you reach optimal performance delivered by what I already mentioned, Uconnect Locate algorithms and the 8 antenna elements and the single RF switch. But it's also a transition from proof of concept to mass production. So in the backside of ANB10, you can see Nina B411, of course, the Bluetooth module. But to the right of it, there's an off-the-shelf pin header. It's a readily available component, so customers can easily source it and put the matching connector on their application board, and they can simply plug the ANB10 board to it and end up with a complete anchor point. So of course we want to give the chance to our customers to evaluate ANB10, and therefore we launched a 3rd Explore kit called Explore AOA 3. This will be available in the beginning of next year, and this time we added an application board to it. So EVB Antoine is an application board that comes with the Explore kit, and it's of course for evaluating and testing ANB10. But by plugging the 2 boards together, you end up with a simple reference design of an anchor point within seconds. And it's a anchor point oriented explore kit, so much so that it includes a plexiglass mounting panel that you can take out of the box and install it right where it is meant to be operating as an anchor point. We also offer the schematics of the application board as well as the source code of the MCU so that you can modify it and have a quick prototype for your own anchor point. A few more details about the application board that is included with the Explore Kit. It has a second Nina B411 Bluetooth module. It has a Wi-Fi module by u-blox, so that you can relay the angles and transport them wirelessly. Or if you prefer a wired connection, there's an RJ45 connector and power over Ethernet as well. There's a powerful MCU for which, as I said, we offer the source code so it can be modified and you can write your own applications, and various other things like connectors and switches. So as I said, this kit will be available in the beginning of next year. So recipients of ANBI-10 samples that evaluated it reported very good results, and they were very happy with the performance of the ANBI-10 antenna board. But some of them communicate to us that it would be very beneficial for them that if they could use a smaller antenna board, a single area antenna board small enough to fit a small enclosure or a small casing. For them, 3D interpositioning as it is offered by ANBI-10 was not necessary. Their application could use 2D interpositioning just fine. And therefore, we took ANBI-10, we removed several of its antenna elements, and we left just 3 of them. And we ended up with a very small antenna board with dimensions 29.5 by 93.5 millimeters. So it's an extremely small antenna board. It's ideal for calculating either the azimuth or elevation angle based on whether it's oriented horizontally or vertically. But everything else is the same as ANBI-10. So on the reverse side, you can see the ANBI-10, the Nina B411 Bluetooth module and the same pin header as ANBI-10. So you can easily replace ANBI-10 for ANBI-11 in a setup like Explore AOA 3. So it's just as simple as unplugging one and plugging the other. So ANBI-11 is a new product. It was announced only last week. So we expect to have it available in the beginning of next year for prototyping and then going to initial production a few months later. So this sums up the line of products that we have available and that comprise our Bluetooth interpositioning solution. I would like to show a slide that has been covered at length during last week Nordic webinar, but it's a good opportunity to summarize a little bit what our solution covers. So if you think of the Bluetooth interpositioning signal chain, we have the antenna board that picks up the transmitted signals from the tag and drives the RF signals to the gray block there that represents Nina B411. And the first operation happens in the radio chipset, part of the NRF5283 chip. So this has the radio capabilities and then the stack that implements the Bluetooth specification. And what comes out of the stack is IQ samples. And these IQ samples are entering the uConnect Locate software, where the angle of arrival algorithm kicks in and performs all the intense measurements. And after some post-processing, what comes out of the Nina B411 is the final angle that you can use for your application as you see fit. It can be just displaying the direction of the tag, or it can be a more complex system like a positioning engine that performs triangulation and alongside the angles that come from other anchor points, determine the exact position of the tag. So this is what is what is covered by the u-blox interpositioning solution. In the next slide, I would like to describe a little bit the accuracy of the system. So we have made several measurements. So here we are presenting measurements taken from a typical average-sized room in our office. We just placed 4 anchors in an 8 by 6 meter room, and we started taking measurements, and these showed that in 95% of these measurements, the accuracy had an error, the angle measurement had an error of below 1 meter. And even better, in 50% of these measurements, the error was below 0.6 meters. So if you would like to translate that to degrees, the phase error was approximately 5 degrees. Of course, there's a lot of things that come into place, and the operating environment and the surfaces and the geometry of the room. Open spaces offer even better performance, but this is a representative use case and a representative set of measurements that show that we achieve below 1 meter accuracy at 95% of the measurements. So next, I would like to show you a few demonstrations in the form of videos that we shot using our products. The first video is a simple angle detection demo setup. It's a follow me application. So we have a tag that moves inside the room, and the signals are being picked up by a 3-element antenna. The u-blox direction finding software U-Connect Locate performs the angle of arrival measurement, and out of the UART it goes to a rotor that is connected to a camera, and the camera follows the person that holds the tag inside the room. So if we can start playing the first video. Thank you very much, Peter. That was our first demo video. So moving on to the second one. This time we have a complete indoor positioning setup. We have placed 6 anchor points in our offices in Malmö, Sweden, and 2 of our colleagues were holding tags in their hands and moving around the room. We use the Traxmate asset tracking platform that I described earlier to set up the anchor points and configure them. We uploaded the floor plan, and on the graphical user interface provided by Traxmate, you can see in real time the position of the tags that are being held by our colleagues. So if Peter can start the second video.
Today we're going to show you how to set up the u-blox Explorer AOA2 Explorer Kit for high accuracy indoor positioning with Bluetooth angle of arrival. The kit contains antenna array boards for the static anchor points, tags for the objects that we'll be tracking, and all the software needed to visualize their positions on a map. To make deployment smooth and efficient, we'll be using Traxmate's asset tracking platform, which comes with integrated support for the u-blox Explorer AOA2 Explorer Kit. This is where we'll be setting up the indoor positioning system. In this case, we will be using Wi-Fi to transfer the angle estimates from the anchor points to the local positioning engine. To deploy the system, we open the positioning engine software and log into the Traxmate platform. The next steps, which we did behind the scenes to save time, involve uploading a map of our building to Traxmate and positioning our anchor points. Traxmate makes it easy to configure details such as each anchor point's height and tilt. Once all the anchor points are deployed and configured, we're ready to start tracking. If we now grab a few tags and start walking around the office, their positions are displayed in real time in the Traxmate tool. The Explore AOA 2 Explorer Kit gives you all the components you need to set up and evaluate Bluetooth indoor positioning. Learn more about the technology and the Explorer Kit at u-blox.com.
Okay, thank you very much, Peter. On the next section, I want to guide you through how to get started and how to get your hands on our solution and start making the most out of it. And definitely the recommendation we have is to grab one of our 3 Explore kits. Explore AOA kits will help you to get familiarized with our technology and our solution, but you will also be able to develop proof of concept implementations, as well as discover new use cases and applications. So just as I said previously, Explore AOA 1 is suitable for direction finding, evaluations and applications. Explore AOA 2 is a complete interpositioning system, and Explore AOA 3 is an anchor point focused reference design. All 3 of them are Bluetooth 5.1 compliant, and all of them support the latest Nordic NRF Connect SDK version 2.1.0. Explore AOA 1 and Explore AOA 2 are currently available, so you can purchase them from any leading distributor out there. Explore AOA 3 will be available at the beginning of next year, so that will be also an option in the very near future. Furthermore, you have more resources available that you can find in our website, except for the classical things like product summaries and data sheets. We have every resource that is available uploaded on there. So you can get user guides for our Explore AOA kits. You can find a user guide for the demo setup that was shown in the second video. You can find very useful white papers. The 80 commands manual is also available, as well as the uConnect Locate software. And as I mentioned earlier, the tag, as well as the Explore AOA 3 reference application board, source code and schematics are also available so that you can use them for your own needs. As of recently, we are proud solution partners of Nordic, and all the products that we described today have been developed as part of this close collaboration that we have with Nordic, and we look forward to see the evolution of this partnership in the future. So to summarize, Bluetooth 5.1 opens up a wide range of new use cases, and we developed a technology that we demonstrated that the technology can deliver sub-meter accuracy. Bluetooth direction finding has many benefits, among them low power consumption, a low cost of ownership, as well as a huge ecosystem of devices that can be tracked. So from evaluation to direction to direct integration to your end product, u-blox is your natural partner for indoor positioning. And Eric and I would like to thank Nordic for giving us the opportunity to talk about our solution and our products. And now we are ready to hear your questions and comments.
Thank you for that great presentation. Yeah, really cool demos.
Thanks.
Right, yeah. There are lots of questions here in the panel, so Let's try with the first one. If anyone has tried using ship antenna instead of the patch antenna for direction finding, so to reduce the size of the antenna board. Well, to my knowledge, I've not seen it. We have been working with different types of antennas within u-blox. We found that the patch antennas give you this performance that we need. We also, I mean, you should also keep in mind that you need to have a certain distance between the antennas, and that's essentially what sets the dimension very much. So it's below 0.5 lambda of the transmitter frequency, so that pretty much sets the dimensions. So you will still not save that much, even if your antenna element was smaller.
Another question is there any way of getting carrier phase information from the receiver? So the carrier phase, I'm not sure if that's referring to the CTE waveform that we use in our receiver to measure the phase difference among the antenna elements. So yeah, the carrier phase information is what our algorithm uses in order to measure the angle of arrival. So
we don't output that information. So we output the angle information from the Uconnect locate. Then there is a question about time sync between the anchors, and no, you don't need to have like nanosecond level time syncs between the anchors. That can be shorted on a higher level. Of course, depending on the accuracy you need or the update rate, but typically these systems are not like microsecond synchronized or microsecond updates. It's rather second update, so there's no need for synchronization.
When can we expect to be able to track hundreds or thousands of assets with angle of arrival? Very soon, I hope, with the u-blox solution. So right now we on a given anchor point on a given antenna board, we can track up to 64 tags simultaneously. So that is relying on a single a module, on a single chipset, on a single antenna, on a single anchor point. If we address this on a system level, then we can increase this number significantly. So we are actively working on implementing schemes where we are doing round-robin measurements of the tags so that we can increase the number, or we can add capabilities like tracking only moving tags and ignoring those that are stationary, or even some more dynamic schemes that can increase this number even further. So we are actively working on increasing this number significantly.
Yep. Then the question, the next question is why Bluetooth 5.1 is chosen instead of UWB for positioning. So I don't think it's a question of choosing one or the other. I mean, they are good for both. They're both good technologies. UWB has an excellent accuracy when it comes to positioning. However, it comes to the cost of power consumption, and also the SoC, the chipset cost is higher for UWB, meaning that it's harder to make it battery operated, it's harder to scale in thousands of tags like the last questions. It will cost you more. So it's a question of two technologies that are complementing each other in our view.
What's the interface between anchor points and computer cloud? Is it LAN, TCP, IP, MQTT, or something else? So that depends entirely on the application board and your specific use case. So the interface between the anchor point and the application board is something that is dependent on the NINA B411 module. So for the time being, we have UART, but we have the option to add more interfaces like SPI in the future. But then between the application board and the computer or the cloud is down to the application. It can be any of these protocols that you mentioned. It's down to the design of the application board.
All right, thank you. Next question, does u-blox provide the angle solver? How can it be integrated with custom applications, and are there licenses involved? So the angle solver, I guess that's what we call the u-connect locate software that runs on the nRF52H33 chip on the antenna board. So that comes with the Explorer kits, as we explained. And it's integrated. It comes with an H-command interface, and you will get the angle data out on the UART interface. There are no licenses involved in the Explorer kits. However, for the end product integration, there is a license scheme set up.
What kind of algorithm you're using for position calculation? Are you using some filtering based on Kalman filter or similar? We spend a lot of time evaluating different algorithms out there. So our team of experts settled on a PDDA-based algorithm. And regarding filtering, yes, Kalman filtering is definitely one of the tools that we've used as part of our solution.
Then there's another question about the number of tags that can go with the solution. So as Joris explained, depending on how you set up your system, for example, tags that are not moving, it would probably be wise to not track them, both for the battery life of the tag and for the system capacity overall. And there are different schemes on how you can add hundreds or have hundreds or even thousands of tags in a system. Of course, the update rate of each tag is also will also affect the number.
What range are you expecting customers to see? That is a very widely discussed subject, and it was also covered by the Nordic webinar. And the bottom line is that it depends. One space from the other is completely different, and there's a lot of factors that affect this, such as the operating environment, the surfaces, the geometry of the room. So it can vary from a few tens of meters up to hundreds of meters. So obviously, an open space is going to have a wider range than a narrow room. But yeah, there's a lot of things that depend on each deployment that will affect the maximum range.
And then there is a question of if we can you extend this to 3D positioning. And yeah, actually we have tested that. With our partners Traxmate, we have tracked Georgios was flying a drone in our office. There was a big atrium hall where we flew a drone, and that there's actually a video on that on YouTube. I think you can find it by searching for u-blox there. So have a look at that. It's fun at least.
So Adbiten is capable of calculating two angles at the same time, both one corresponding to azimuth, the other to elevation. Therefore, you can do 3D positioning. Are you also calculating angles on nRF5283? Well, the nRF5283 is a chipset that we have integrated inside the NINA B411 module. The calculation itself, the angle of arrival calculation happens outside of the chipset. So the chipset gives out IQ samples, as was covered by the Nordic webinar. There you can find a lot of information on what is covered by the chipset and what is covered by the integrated module.
But Georgios, the angle as such is calculated then in the Cortex M4 in
the CPU, yes, yeah. So not the radio that produces that converts the signals. Sorry, I misunderstood the question. Yes, in that way, yes, of course, it's that also happens inside the CPU of the nRF5283. Yes.
Thanks. Then there are two questions about UART connection. So the ANT-B11 has a UART connection, so the angle data is output on the UART connection. And also on the Explorer AOA 3, there is possibilities to from the application board, right, to get an UART connection out if that's preferred.
Yeah, I believe that that's a very similar question on top. Explorer AOA 3 have UART connection. Yeah, so as I said, you can take the UART interface from the Nina B411 from the ANB10 board and drive it to any of the external interfaces of the Explorer AOA 3 application board. So this can be Ethernet, or it can be Wi-Fi, or it can be USB, or anything. Does the Ethernet interface on the EBB Antoine carrier board have hardware timestamping? This would allow a set of anchor receivers to be set frequency synchronized. I believe so, because that's one of the applications that we are planning on testing. So I believe that it has this capability, but I will have to check with our hardware designers to give you a more comprehensive reply.
Right. Yeah. The next question: can ANB10 be used for custom designs products that are not by u-blox? So yes, that's the idea of the ANB10. It should be it's done to be integrated into customer designs of any kind that you prefer. So that's essentially a component, a subcomponent in the system.
Will you be releasing the source Gerber's algorithm for these products? Yes, for some products. So, for example, for the tag that we give with our Explore kits, as well as the reference application board that comes with Explorer AOA 3, yes, we will give out schematics as well as the source code for the MCU that is on the application board that comes with Explorer AOA 3. The algorithm, if you mean the angle of arrival calculation algorithm, the uConnect locate software, we will not give the source code for that.
All right, then there's a question: if we have three receivers in an AOA system and they're spaced 50 meters apart, and if one of them can be used to triangulate the AOA signal, I believe that's what the question is. So you could have your triangulation done in one of the anchor points, having that kind of a master anchor point, if you like, that collects the data from the others. That's possible. It's not something that you would do in the nRF52833 chip, but it would be done in a host processor.
Could you reflect on power consumption in a use case of your choice as an example? Well, the power consumption depends on several factors, such as the update rate, and there's typical values that you can find in our data sheets that we have uploaded on our webpage. So I would recommend that you refer to these typical values that are included in our data sheet.
Okay, the first video demonstration, how many anchors did you have set up there? And that was only one anchor point, just behind the camera. There was one following the person moving in front of it.
It sends IQ or angle to Traxmate. So the inputted Traxmate is the it's the position. Actually, it's not the angle. So basically, what happens in between the ANB10 and the Traxmate, there needs to be a positioning engine which is external to the antenna board. So the positioning engine collects angles from various antenna boards and performs the mathematical operations such as triangulation. And it's the output of the positioning engine that goes in the Traxmate platform.
Then there's a question about sport watches. So many consumer products such as sport watches and heart rate monitor use chest straps, use older Bluetooth versions. Do you expect these kind of devices to move to Bluetooth 5.1 and enable the CT feature? Well, the honest answer is that I don't know. This is not a domain where we are that active in these kind of products. So I'm afraid we don't have an answer to that.
I can try to answer it.
Okay, yeah. Go ahead. Thank you, Petter.
I mean, the SoCs that we provide, they provide these functionalities as standard, and so it's possible for customers to enable this, but it's a bit of a chicken and an egg problem. If you don't have the systems around to kind of take advantage of this, then it doesn't really make sense to have the functionality in the product either. But if this is something that is adopted in, for example, airports or other places, then this is something that product manufacturers can put into their products, and yeah.
What is the advertising interval of the tags in the demo? What is the approximate battery life for the tags in that advertising rate? Unfortunately, I can't remember that off the top of my head. I'm not, but it must be. It's not a very high advertising rate. It's just it was just done for demo purposes. So I believe it's a few angle measurements per second, a few hertz at least. So again, I would kindly ask you to refer to our documentation for the power consumption values so that you can determine the approximate battery life for that.
Yeah. Next question is, what's the delay between the tag being moved and this movement being represented in the GUI? On the demo video, it seems that is around 1 second, so reactiveness is not high. Well, yeah, it's probably that second time is probably what we're looking at. This is not a kind of ultra fast system, both in terms of the calculation that needs to be done and the transport of this data up to the cloud-based GUI. So it's in the second. 1 second is probably accurate here, as you referred.
Is it possible to use another algorithm with a u-blox pre-processing? No, this is not possible. So if by pre-processing you mean the antenna board comes with Nina B411. That is not a possibility. No.
See. So can you give us an idea of the static angle accuracy at 10 meters? So we say that the typical accuracy is around 5 degrees. That's what we've measured with our kits. So that's and 10 meters is probably an accurate distance that should be fine.
When multiple receivers are used in angle of arrival computation, can one receiver be fixed and two receivers be mobile? I believe that this was covered by the Nordic webinar last week, and it is possible, but it's a bit challenging. So I would refer you to this webinar, but it's a tricky situation. I believe it is feasible, but that's not a typical use case that we have put to test.
Yeah, outside of asset tracking, what areas do you expect the most growth, short term and long term? Well, we believe part of the use cases that we described in the beginning, like access control or different kind of follow me applications. It could be air purifier following a user or a tag, so you can easily direct it to where you want to have the fresh air. Those kind of applications we've seen. So I think those we expect to be growing.
To measure an angle, theoretically, two antennas are needed.
more of a
Sorry,
statement. But yeah, but to get any good performance, we have found that free antennas is needed to handle multi-path effects and so on.
Yeah. Yeah, how the tags are identified from each other. So each tag has a unique ID. So by tracking the angle at the same time, we output the unique the unique ID that each tag has.
What is the advantage with 3 or 8 antennas? Well, obviously, with 8 antennas, you have a more robust system. You have more antennas to use for your calculations and more data, essentially. So that gives a more accurate and more reliable, robust result. But we've seen that we can we can see really good results also with the free antenna solution. And that's the benefit with the free antenna is, of course, that it's smaller and it's faster.
How does the accuracy of location compare to ultra wideband? I believe that this has also been covered at length. Ultra wideband in terms of accuracy has an advantage compared to Bluetooth because of the technology it employs, but there's other things that also affect the comparison between ultra wideband and Bluetooth, such as the power consumption as well as the cost of ownership. Additionally, Bluetooth is capable of tracking more devices. There's a vast ecosystem of devices that can be tracked by Bluetooth, especially as the Bluetooth 5.1 specification has more devices that support it.
All right. Is there any limitation about the beacon position? Example, should it be between 20 and 80 degrees? Yeah, well, it's a good question. Typically, the antenna will not cover the full range, 180 degrees in front of you. So we estimate something like 15 degrees on both sides, that where the results are worse than in the main area in front. So something like that, 15 degrees on both sides.
Are samples available? If you mean samples for ANB10, the antenna board, yes, there are samples available. ANB11, we will also have prototype samples available in the beginning of next year. So you can get in touch with a u-blox, your local u-blox sales representative or FAE, and we can take it from there. The Explore kits, as I said, Explore AOA 1 and 2 are available as we speak in any of the leading distributors, and Explore AOA 3 will also be available in the beginning of next year.
Would a line of sight between antenna and the tag impact performance? And yes, so a line of sight gives you good performance. If you don't have line of sight, well, then performance is worse. You don't necessarily need line of sight between your tag and free antenna boards to get a position. You could see in the video where one of the persons were walking into a conference room where there was only one antenna board in that room, while the other ones where there was a line of sight to that one, of course, but then the other antenna boards, there wasn't a line of sight, but still we could position that person pretty accurately.
And does u-blox provide production-ready anchor or antenna board? The antenna board is production ready, so we will go to initial production at the beginning of next year. In terms of anchor, we have the antenna board and we have a reference design for the application board that you can take the schematics and apply it to your needs. So yeah, the antenna board, yes. The complete anchor points, we will give you the reference design for the application board if you need it.
Mm-hmm. Then there is a question about if there is a solution for working with mobile phones and the antenna array. To my knowledge, there are no mobile phones yet that provides the CTE functionality that is needed on the tag side. So unfortunately not.
Does u-blox provides the positioning engine? Yes, we have a reference positioning engine that we give with our Explorer AOA 2 kits. So you can use that for that setup, and of course, depending on your needs, we may be able to help you apply it to your use case as well. Yeah.
Have you attempted multi-floor environments? Would you use one set of antennas per floor? Yes, you would need that. You would need to have separate antennas on each floor to determine the position correctly.
I'm sorry, I'm lost.
There's a question
is there a relationship between the installation height and coverage area? Yes, there is a radiation pattern, or a specific radiation pattern that each of our antenna board has. So based on that, yes, there will be an effect on the coverage area depending on how high the antenna board is installed. Unbitten that has both azimuth and elevation angles. It has a better coverage if you place it on a ceiling up high, so you can have a better coverage with unbitten compared to NB11 that has only a single array of elements.
Okay, thank you. And then there's a question that u-blox would be willing to sell samples if we don't have, if there isn't any ongoing customers. Well, of course, as Georgios explained, the Explorer IoT 1 and IoT 2 are already available on the
AOA.
AOA, sorry.
It's okay.
we have another IoT kit, yeah. So they are already available from the global distributors. The NB10 is also once we have ramped that up, that production in Q1, that will also be available for anyone to purchase. So there's no restrictions on that.
And I believe that's the final question, unless I'm mistaken.
Yep.
What's the positioning latency real-time scenario? That depends on the positioning engine that you're deploying. So it depends on how fast the mathematical operation, how fast the triangulation happens, how much filtering or smoothing there is in the received angles. So it depends. It can be fractions of a second, or it can be several seconds.
Okay, then I think we're a few minutes over time, and we have answered all the questions. So that's really good. Thank you, Erik and Georgios, for presenting and answering all the questions. And thank you to everyone out there watching.
Thank you very much, Peter, for giving us the opportunity to present our solution. And we welcome any questions you may have. You can reach us after the webinar, and we'll be happy to address them as well.
Great. And lastly, just want to remind everyone to register for our upcoming Nordic Tech webinars. You can do that at www.nordicsemi.com/webinars. Thank you. Have a good one.